Cool. We're live. It's a shame I have to do this, but oops. Let me switch my camera. Nice. Okay. Is this working? Yeah, it should be working, isn't it? Desktop audio mic aux. Alright, let me post this to the TL, to the feed. Should really do it QRTing it. Be better. Be better off. Oh, and I need to figure out the TTS. Right. Goal of this stream is pretty simple. Pretty simple. Before I continue, where's my TTS? TTS, sorry, text to speech. Uh, Funny. No, voice generator. And it takes ages. Fine. Fine, I'll read it. I'll read it. I'll read it, it's fine. Cool. Right, as I was saying, the purpose of this stream is to go through this, the technical regs for next year's F1, just to try and see if I can really find anything. So it should be interesting. I understand this will be boring for some of you, which is why this is quite frankly ingenious from my part. I have here some Subway Surfers footage, 10 hours of it, just in case you guys think I'm boring. So, open this. And also, I want to go through the sporting regulations at some point to see if the exploit I talk about, that being the being able to do power tracks like Vegas on max downforce settings, if that's even allowed or not, because I see that I don't. What was that? Chat, hold on. Was that the smoke alarm? Uh-oh. I haven't even streamed for 5 minutes and I've already got the smoke alarm dying on us. So yeah, that's cool. Oops. Right. Yeah. So, as I was saying, I don't really think it's I don't really think it's a case of let me drop this just in case. It's gonna get in the way a lot. I don't think it's a case of technical regulations. I think it's more so sporting, because in reality, nothing is stopping a team in 2026 with active aero to, I guess, run an F1 car with max downforce because in first place, you get to a straight, down goes the flaps, you cruise along. You cruise along pretty well. That's my initial assumption right now. And then you get to a shot, you get to a really slow corner. You use in this case, you use an air brake. Like, oh, come on, man, this guy sucks. You use an air brake generated by the front and the rear wing to provide extra braking power, like in the form of aerodynamic drag. And because you've got maximum downforce, you can take corners at higher speeds, the slower corners at higher speeds than normal. At least that's my initial assumption. So, let's go through it. I'm gonna put it here so I can read this properly. That's also not messing with my webcam, is it? No, we're fine. Alright, this is public information. If anyone wants to cook me for it, then it's public information. That's all I'm going to say. Alright, what we got here? General principles. Conventions and fundamental dimensions. Aerodynamic components. So from C3 you get to the juicy stuff. Then C4 is again a bit more boring. Power units. This is another juicy bit that's just opened up now. One of the assumptions I want to see from here is whether or not silicon carbide technologies in batteries is allowed or not, because that solves all of the power issues that you have. Like, for example, in Monza, the drivers are saying you can't really go. You run out of hybrid power halfway down the straight. That's not good. Silicon carbide batteries fixes that. So I'm assuming. So I've got a couple of assumptions. A, you can use it and no one, unless that's part of the gentleman's agreement that they've made to, hey, limit the power output to so-and-so this month, to so-and-so. Or B, maybe they already have it, and, well, if so, then if they have it on their power units, then yeah, I am stumped. I've got nothing else to say for it. Then you've got fuel. Again, pretty much standard. But there could be something here. I mean, these fuel, oil, and coolants, that's just pretty optimized already. So there's not really much I could say from there. Electrics. There could be. With the increase in electric power, I think that some teams can start to learn from things like Formula E, where they just. No, actually, no. That comes under power unit, doesn't it? Because I want to say, hey, you could optimize your electronics and your softwares like the people doing Formula E, but yeah, it's power units, not electrical systems. This is just telemetry and so on. So there may be something here, but I don't think there will be. Transmission system. Again, pretty niche. Now this is interesting. This is another juicy bit, similar to the suspension, and the same goes with the brakes as well. Survival cell. This is pretty optimized. No one's gonna. Same goes with safety homologation and safety equipment. So yeah, but brakes and suspension, that's pretty much free play, which makes it interesting. What else you got? Safety equipment, yeah, optimized. Permitted materials. Could be a bit This is what I'm talking about with the silicon carbide. Yeah, we'll have a look at that. Fuel and engine oil. I mean, yeah, it's niche. I'm not sure if I'll cover that. Then you've got the appendix and the power unit classification. This is all pretty standard stuff. This is something I don't think we'll cover. This is... This is just to help people out understanding things. So, like, so you guys, for example, who I'm talking to. Alright, general principles. Yes. Yes. Honestly, this isn't... I'm not reading these out very often because it's just standard stuff, honestly. Hold on. Any terms not defined in these technical regulations have the meaning given to them in the FI 2022 technical regulations. Do they? In the event that ascribing the meaning of a defined term in the 2022 technical regs to an undefined term in these technical regulations results in a significant impact to the 2026 power unit design. PU manufacturers bound by these technical regulations may ask the FI for guidance, and then they will issue it in the form of a technical directive. Such guidance will be communicated to the PU manufacturers. Okay. No one will do this. No one will do this. Unless there's already a drama going on. Any amendments to these regulations do not relate specifically to the power units, or relate to matters of form such as renumbering, blah blah blah. Okay. Yeah, this is standard stuff. Fundamental dimensions, okay. Car coordinate system. Definitions. So there's your definitions if you want to know what they're talking about. So the x-axis being... you know what? I'll get paint to illustrate this. Here. X-axis being the longitudinal direction of the car and increases rearwards. So you have a track like this. The x-axis is this way in layman's terms. The y-axis is the transverse direction or the lateral direction and increases to the driver's right hand side. Well, x is taken rearwards, so this is technically this is negative, so y is here and then z is vertical here. So yeah, pretty standard stuff. Pretty standard stuff. Everyone's done that. It's just for use later on. This is like a tool. This is a sort of useful tool that we'll use for later. If no units are specified, it's implicit that it's in millimeters. Again, pretty standard stuff in engineering. The terms inboard and outboard, when used in reference to the y coordinate, refer to closer or further away from the plane. Yep. Suffix may be used for local coordinates. Yes. So a suffix being any given component in a car, like say, for example, the front wing. We'll use this red curve as the front wing of, say, a Ferrari. That can then impose its own coordinate system in the same way as the rest of the car. Planes will be referred to the axis as which they're normal to. So planes being like certain components of the car, such as the front wing, the rear wing. That's also a plane. The wheels and tires, the brakes, etc. A wheel is defined to be in straight ahead position when its rotational axis lies in an x-plane. Yeah, so longitudinal. Straight ahead position, yeah, practically. So think of it when the wheel rolls forwards. And then unless otherwise specified, the positive side of the y-axis is used in the various articles, and it's implicit that a symmetrical rule applies for the other side of the car. So, line of symmetry. Again, standard stuff. Standard stuff, you see this everywhere. Any measurements and references with wheels are given in the straight ahead position, so rolling forwards. When a viewing direction is stated, front and rear are parallel to the x-axis, side is parallel to y. Front and rear are parallel to the... Yes, that makes sense. So, this for example, point of view, this point of view that I've created right here. Front and rear parallel to the x-axis, check. Side is parallel to the y-axis, and then above and below and planar parallel to z. Check and check. Directions of angles, slopes, and incidences are taken in the context of the right-handed Cartesian coordinate system, as I've defined already in paint. A positive slope within a y-plane would be characterized positively by increasing x and z. Oh, I see. So, a positive slope, say a side pod. Let's use this as a side pod. Put dashes in it and everything. So, this is on the y-plane. So, this sidewards plane here. Increases are made in the x direction and the z direction, upwards. Like so. References to axis-aligned geometry are aligned to the car coordinate system. And the same thing goes with load vectors. So if you have loads like going through it, or for like hanging weights off of, say, the front wing or the rear wing, then yeah, these are also used in this same system. Like, for example, for wing deflection tests. Alright. Wheel coordinate system. It's just the same thing, but for wheels. We'll refer to this if we need to. Principal planes. Okay, these are all of the planes. Z equals 0 is the bottom of the car, except for the plank. Except for the plank, that's key. Why? Plank wear, that's why. Y equals 0, plane of the symmetry of the car. So, the symmetrical line. Here. Also, that's not the Y plane. That's a mistake I've made already. XA is the forward limit of the survival cell. So, an illustration of an F1 car. For, this top-down view of the Red Bull. The Red Bull 20. The forward limit of the survival cell being here. bit after the wing that can get removed, and the suspension. Oops. XC? What is XB? Oh, XC is the cockpit, which is self-explanatory. XF and XR are the X-planes which pass through the front and rear wheels, here and here. Let me move this away. Move this out of the way. XDiff is the axis of rotation on the final drive, which is the axis of rotation of the differential. The XPU is the mounting face of the connections between the engine and the survival cell, or here. I think it's this bit above the air, just below the airbox. XFIS is the forwardmost point of the front impact structure, which would be the front wing. Except for the tyres, the wheel rims and parts attached to the wheel rims are defined. No part of the car may lie more than 950 mil from the plane Y0 at legality ride heights. Width. No part of the car may lie more. Oh, I see. So this is just... this is simple. The width of the car being here, or at least the center line from the front of the wing to this end here of the side pods, or in paint terms, this distance here, for example, that's 950 mil. It cannot go over that. At legality ride heights. Yeah. It can't do that. It can't be more than that because otherwise the car's too wide and it's illegal. I think yeah, you all saw that James Hunt scene where they said the car was too wide or something. And yeah, that's a good explainer. Height. Except for the plank assembly, no part of the car may lie directly below the trim and combination of the RV floor body, the bib and the foot, the sidewall and the fence. Oh, here's an interesting one. The wheelbase must be less than or equal to 3,400 meters. So that's the distance from the front wheel center to the rear wheel center at the legal ride height. And this must be the legal ride height. The front wheel position must, or the plane, must lie between XA is 0 and 150. We're just here. Oh. Yeah. So, I'm guessing for safety purposes. Because if the front wheel's too far back or too far forward, it could cause a proper accident. We don't want that, do we? Cockpit position XA0 and XC0 must be greater than or equal to 1830. And less than or equal to 2030. So, distance here to here. So this allows for a bit of leeway. Or does it? Let's think here. Let's think here. Distance between XA and XC. So the survival cell and the cockpit. Yeah, this is just for driver comfort. This is just if you're short or tall. Like if you're between Sonoda and Ocon, size-wise. Rear bulkhead position. Distance between the cockpit and the power unit mountings must be greater than or equal to 360. I guess for padding purposes. And ensuring the driver doesn't, you know, overheat from the back. Not that it would matter to them. Reference volumes, reference surfaces and their position in space and defined in a car coordinate system. Any numerical values will be considered to the limit, regardless of the decimals quoted. Alright. Alright, here we go. Here's the fun stuff. Aero components. Aerodynamic components or bodywork are parts in car in contract with the external airstream. Bodywork is every component in this article. Inlet or outlet cooling ducts. So side pods. Side pod ducts, or those cooling ducts that you see here. Heat exchangers. Inlet ducts to the power unit. So the airbox. That's bodywork. And heat exchangers. That's covered later. Cameras and camera houses are not bodywork. The ERS status lights. Rear view mirrors, obviously. Parts associated with the mechanical functioning of the powertrain. Transmission of the power to the wheels and the steering. Provided none are designed to achieve an aerodynamic effect. Here we go, here we go. So, okay. So what they're trying to say is, if parts like the steering, as shown here, are designed to reach an aerodynamic effect, then it's considered bodywork. If not, then no one cares, and it's got its own section for it. Wheel rims and tyres. Brake disc assemblies, calipers and pads. CCU antenna, it's new. Okay, so... Oh. So already we have something juicy. Primary objectives of Article 3 are blah blah blah, to promote close racing, blah 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 blah. Blah 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 blah. To ensure aerodynamic performance remains compatible with the performance of the blah 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 blah. To assess these objectives, F1 teams may be asked to provide relevant information to La FIA. The IP of the information remains with the F1 team, will be protected and will not be disclosed to a third party. Okay. Except for the driver adjustable bodywork specified when in a state of deployment only, minimal parts related to their operation and aerodynamic and flexible seals allowed are all aerodynamic components or bodywork must be rigid and immobile and provides an impervious, solid, hard and continuous surface at all times. So basically, any redundant stuff must not flex and along with all aerodynamic components and bodywork, they must not flex relative to their frame of reference, and must not be porous. This is interesting. This pink stuff is new. Driver adjustable bodywork when in a state of deployment only. So whenever you're deploying battery. Driver adjustable bodywork. Ah, right. Yes, I see. So I'm stupid. That's the active aero. Just say active aero, man. So stupid. Alright. Where an aerodynamic component complies with the test defined in Article 3.1a, it will be considered compliant with A for the deflection tested. Oh, this. Oh, right, yeah, okay. Any device or structure designed to bridge the gap between the sprung part of the car and the ground is strictly prohibited. So that's anything. It's just to stop you from active aero, because yeah, it's a movable aerodynamic device. Aside from necessary parts for the adjustments described in the following articles and incidental movements from the steering system, any car system, device or procedure that alters the aerodynamic characteristics of the car through driver movement is forbidden. So no DAS. No DAS and no F-ducts. Furthermore, the aerodynamic effect of any component not classified as bodywork must be incidental to its primary function. Designs intended to enhance any such aerodynamic effects are prohibited. Oh, come on, man. Must be incidental. Oh, I see. Okay. So, if you want, you remember the steering system we talked about not so long ago? If you want that to have a benefit to the car, then it has to be classified as bodywork, which is under its own stringent measures. Symmetry. All bodywork must be nominally symmetrical, yeah. No asymmetric stuff. Minimal exceptions are accepted for the installation of non-symmetrical mechanical components. Yeah. For asymmetrical cooling requirements. So what Ferrari gave to Charles Leclerc's car in Hungary, or for asymmetrical angle adjustment of the front wing primary and secondary flap, provided this adjustment is not controlled by the F5 standard ECU. Well, the thing is, I'm glad teams are finally starting to invest in asymmetric cooling, like make it circuit specific, because hey, it's pretty cool. It's the heart of the sport, what I'm hearing. Asymmetrical cooling requirements, asymmetrical angle adjustments of the front wing primary and secondary flap. Whoa, 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 whoa. You're telling me minimal exceptions to the requirements of symmetry. So exceptions to this. asymmetrical angle adjustments of the primary and secondary flap, but it needs to be, but it needs to not be controlled by the FIA standard ECU. So this is basically like flap changes in the pits. They don't want anyone, well, developing their own electronic system to get asymmetrical wings. And even then, if someone manages to crack this, they could. If someone manages to get around this with their own system, then you could have an asymmetrical front wing or rear wing. Well, front wing mostly, but hold on, let me think here. Let's think here. What's stopping me from coming into the pits and changing the flap, obviously, and then opening the flaps afterwards? I mean, it's an adjustment, but it's not controlled by the ECU. It's changed mechanically, which I can then proceed to use for the rest of the race. No. So, say for example, I want in, let's say, Monza to have. Hold on, let me. Let me say something. Say for Monza, for example, with a Sactivero, I could. I come into the pits and ask them to increase one side of the wing more than the other, and then I can abuse the straight line speed gains because it's Activero, and still gain a lot more in the corners because the flaps are like that. Is that allowed? Is that technically allowed? There's nothing here telling me no, because it's not an asymmetrical angle adjustment. It's well, it is an asymmetrical angle adjustment, but it's not controlled by the ECU when you adjust it. It's controlled by the two men adjusting the flap on the front wing for balance. I mean, people do this all the time, but the balance is just gonna vary a lot more. Bodywork on the unsprung mass must respect this article. When the suspension position of each wheel is virtually reoriented, so that its wheel coordinate system axis are parallel to the that's fine. It's just basically make it parallel to the axis of, make the wheels parallel to the axis of the car coordinate system. Don't make it flex to gain an advantage on the toe or the camber or the whatnot. Component bodywork. Unless otherwise stated, all individual bodywork components prior to any trim and combo operations and before the addition of openings must be single volumes that are simply connected. It's fair. Any X, Y, and Z plane or any X, W's only contain a single. Yeah, that's fine. A trim and combination operation that can be performed once the parts to be trimmed are fully defined. The only regions of a volume that can be removed as part of a trimming process are those that are internal to the body that they are trimmed by. Once parts are trimmed and combined, and any fillet radius or edge radius permitted by the relevant article is applied, the resultant volume must maintain both continuity and tangency in any X, Y, and Z plane at the boundaries between the adjacent sections of the parts, unless otherwise stated. The elective trimming of volumes beyond or outside of any overlap is not permitted, and it must result in a single volume. Oh, so like when Red Bull brought the wrong rear wing to Las Vegas last year. Yeah, who remembers that? Fun times. We thought we Lando fans thought we were still in with a shot, but now they just trimmed the rear off. We thought it was funny, and then Max won. Yeah. Red Bull's unseriousness. Yeah. Something. So yeah, they took advantage of this rule, this trim and combination. But they had to define an area to trim off, and it had to be symmetrical. And it cannot overlap and result in a single volume. Yeah. Fillet radius is formed by rounding an internal corner, including angles less than 180 degrees, with a concave surface by only adding material. Edge radius is created by smoothing an external corner with a convex surface. In both instances, the resulting surface must consist of arcs that adhere to specified radius limits, connect two fully defined surfaces tangentially without inflection, and align perpendicularly to their intersection. So this is just to basically allow, just to prevent any additional aerodynamic gains from this. No, that's no good. That's no good. And they have this locked down. They must maintain both continuity and tangency with the filleted parts fit within an acute circular cone whose base radius is 1.2 times the minimum radius necessary to fully enclose the preceding fillet radii. This is for like the nose, then. Height is 3 times the maximum trailing edge of the fillet radius. Comply with component body. Ah, yeah. This is for like, yeah, for curvatures. Pressure tappings. Pressure measuring apertures are permitted on the car provided they have an internal diameter of no more than 2 mil, are flush with the underlying geometry, and are only connected to pressure sensors or are completely blanked. This is just measuring air pressure. It's just on the bodywork. You know those little where is it? This little probe here, that's what they're talking about. And there's probably one around here as well. Or somewhere else on the car. Section and titles within article. What? have no regulatory value. Well, I guess for this, yeah, this is irrelevant. Yeah, thanks for that, mate. Legality checking. This is for tests. Assessment of geometric compliance will be carried out digitally using CAD models provided by the teams. Components may only be designed to the edge of a reference volume or within precise geometrical feature, or to limit a geometrical criterion, say for the normal round-off discrepancies of the CAD system, when regulations specifically require an aspect of the bodywork to be designed to its limit, or it can be demonstrated that the design does not rely on lying exactly on this limit to conform to the regulations, such that it is possible for the physical bodywork to comply. This is just checking things match and things don't match. Just make sure things aren't too wide or out of symmetry or whatnot. B. Components must follow a precise shape, surface or plane, must be designed without any tolerance, save for the normal round-off discrepancies of the CAD system. Yeah, that's fine. Bodywork required to be visible from a prescribed direction may include surfaces parallel to the direction, provided it can be shown that such parallel surfaces could instead be drawn at an infinitesimally small included angle and comply with all relevant articles. So this is if you've got a piece of bodywork from a specific direction, say here, you need to include surfaces. You can include surfaces parallel to the direction, but it needs to be drawn at an infinitesimally small included angle while complying with all relevant articles. So it needs to be drawn by an Adrian Newey approver. Basically someone who uses Adrian Newey's drawing methods. Physical legality checking. Cars may be measured during a competition to check their conformance to the CAD models. Yeah. Unless otherwise stated, a tolerance of 3 mil will be accepted for manufacturing purposes only with respect to the CAD surfaces. Where measured surfaces lie outside of this tolerance but remain within the reference volumes, an F1 team may be found. You know what? Let's keep a tally of the loopholes here. LH, not Hamilton. ... We've got one loophole so far with the flaps, the asymmetrical flaps, which can then be actuated. Well, I'm not entirely certain, but I think it could be a loophole. Anyways, tolerances of 3 mil, reference volumes. Positional tolerance of 2 mil will be accepted for the front wing bodywork, rear wing bodywork, exhaust pipe and tail. This will be assessed by realigning each of the groups that define the assemblies. Just make sure everything fits, really. Yep, okay. Tape, provided it does not achieve an aerodynamic effect. Datum points. All cars must be equipped with optical target mountings in the following locations. Otherwise stated, all positions have 2 targets positioned symmetrically about y equals 0. 1 on top of the survival cell. Well, 2 on top of the survival cell. On the side of the survival cell, close to the rear mounts of the secondary raw structure. This is just for during the race. This is just cameras all around the car, so that during the race they have no reason to suspect that anything's gone wrong or illegal. a single point on the gearbox case. In all cases, a file containing the coordinates of the required datum points must be supplied for each survival cell. Full details of the requirements are given in a different document. Supports for scrutineering. All cars must be equipped with 4 pads. Yeah, there's just support pads to hold the car up. And they have to stay on the car, I think, unfortunately. This defines the locations. Component definition. The permitted bodywork and relevant frame of reference for each group is defined in the following articles. Bodywork part of the sprung mass of the car. The only permissible sprung mass bodywork is defined under Articles 3.5 to 3.13 and Articles blah 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 or frame of reference is the car coordinate system. Yes, this is just it's just the bodywork stuff now. The only permissible wheel bodywork is defined. Use of components not defined as bodywork to achieve compliance with the bodywork is not permitted. After final assembly, provided any modification does not result in the surfaces becoming aerodynamic surfaces, you can modify the ducts and non-aero surfaces. The fairings are defined in a different section. Hanger not sure what they mean by hanger. Floor bodywork must lie in its entirety within RV floor body, and it must fully obscure the ice and the diff, and has 2 sections in the Z-plane. The floor foot must obscure things. The floor sidewall must lie in its entirety. The main floor combines all of this. Fillet radius must be simply connected. It's just to make sure that no floor's weird. Main floor aerodynamic surfaces must contain no radius of curvature less than 25 mm, except for within 5 mm of the plane view boundary of the main floor when viewed from above or below. Within 45 mm of a single point that lies in the floor sphere. Of convex curvature, visible from above and within 10 mm of the load application points. Within 5 mm of the fillet radii, permitted as part of the main floor trim and combination. Where the radius of curvature must be no less than 10 mm. Floorboard bodywork must lie in its... Oh, okay. This is just telling people, hey, listen, no ground effect. This is, the RV floor sphere is what I can only assume is the rear diffuser. Floorboard must have up to 3 sections. Floorboard aerodynamic surfaces, so that's the fences here, I think. Nope. It must have a normal with a positive x component, a tangent that forms an angle of at least 15 degrees to the x, and contains no concave curvature less than 100. It's just to stop people making aerodynamic floors. What was concave and convex again? I forgot. Yeah, okay. That is diffuser related. Okay. Well, technically. You could probably do something here. I think you could. I'm not sure. With it's more shape dependent, I think. Floor bit bodywork must be visible from either above or below. Again, this is just fences on the floor. No concave radius of curvature. Visible from below, less than 50 if visible from above. The floor leading edge device must lie in its entirety within the RV floor. Have up to 5 seconds. And the leading edge must be no less than 4 mm thick and contain no convex radius of curvature less than 2 mm. Then the floor winglets, which is the... Winglet profile aerodynamic surfaces must contain no concave radius of curvature. Less? Once trimmed and combined, floor winglet and the annotated surface trim surface may only be modified together and in the following order. Rotated by 5 degrees about a... and translated. Floor winglet trim below the annotated surface. This is just defining the floor and telling people, hey, no more ground effect, so yeah. But someone's still gonna try and do something with it though, I think. One of the teams will. It's worth a try. This is a combination of this. Yep. Goodness, I'm getting bored and tired. What's the how long is this going? Goodness. Once the floor bodywork has been fully defined and the floor's been completed, up to 3 floor body stays, which may be designed to take load and tension, and each of which must have a single inboard attachment that lies between XF and XR. Hold on a minute. ¿No esté arriba del todo? Smoke alarm again. Sorry, chat. It's warm in here, that's the thing. Single fairing must be shrouded. Contain only one... Not closed, just one section. Fillet radius no greater than 20 mm may be applied along the intersection between floor and other bodywork. The upper surface must not be in contact with the external airstream. Just preventing extra ground effect there. Geometry must conform to the plank. The plank assembly must have 3 34mm diameter holes. That's how they measure this. Yep, that's how they measure this. Must be uniform when you... Yep. Yeah, this is how they check. If you're curious, guys, this is how they check plank wear. Evaluation, they just drill holes in it and look at it from underneath, see if they reached a certain limit or not. Kind of like checking your tire tread wear. Evaluation of skid wear will be made by physical measurement of the skid with it removed from the car. The measurement will be made by The following provisions apply to the plank. The material, you can be anything, but it must be homogeneous with a specific gravity between 1.3 and 1.45. Or if pocketed, be made from a bonded assembly, which must have a specific gravity as shown. And the remainder, excluding pockets, be made from a homogeneous material. So you can use any material you want for the plank, but it needs to be of a specific gravity. The plank may comprise no more than 3 pieces. The forward one is just defining the length of the plank. Here's the skid material debacle we've been having this year. A metallic skid is mandatory around most of the forwardmost plank hole, and it's optional around the middle and rear plank hole. If a metallic skid isn't present, it may be either replaced with a separate piece of plank or integrated into the plank, which is a disadvantage, I think. Resulting geometry must contain the hole and counterbore detail present. The skid material must be made to the geometry defined and associated drawing. Be divided into 3 separate parts, fastened directly to the front floor structure with 0 degrees of freedom, so it can't move. If metallic, then the skids in the center and the rear must be made to the geometry and divided into 3 separate parts. They can either be made from TI6 AL4V, according to AMS, this in annealed condition, or stainless steel with hardness when new less than 37 HRC. They may only be machined from solid, and no processes such as forging, rolling, welding, additional heat treatment or coating, just to increase the further increase the strength of the material, may be carried out either before or after machining. Right, okay, so this is just telling people, hey, we don't want your skids being... We want your skids to be of these 2 specific material. usually the material's metallic. Like, imagine having a stone skid. Would just wear off fast. They choose metal because it's hard. It's a stupid statement, yeah. But yeah, there's really not many materials that are harder than these two. And they just define two specific materials and just tell them you can't heat treat it, you can't do this, that to make sure the strength increases, whatever. They must be mounted using M6 bolts. This is niche. Too niche. Nodes. Here's more interesting stuff. When viewed from above, it must fully obscure it. Nose aerodynamic surfaces must be tangent continuous. So it must be continuous to a certain tangent. And in any X-plane must contain no concave radius of curvature. So by tangent continuous, they mean it cannot be like completely flat and still in contact with it. You can't have any weird sorts of noses. Tangent to the z-axis at its outermost extremity. Contains no radius of curvature. Contains no radius of curvature. Cameras in position 2. Mountain brackets, yep. These are just exemptions. Forward chassis bodywork. Must not be concave or convex. No concave radius or less than, except for regions within the secondary roll structure and 25 mm of the aperture. No convex radius of curvature less than 25 mm below C200. Roll hoop. Mirror body must lie in its entirety. Not much you could do. Yep. Fillet radius. Driver cooling. Must be fully visible, yep. Yep, to prevent aerodynamic gains. Fillet radius no greater than that. Yeah, this is just telling people don't go overboard with the side pods. Yep. Uh-huh. Two sections. Remain unobstructed. Single tail Python support. Gurney flaps, yep. Pylon straight. Oh. Oh. Whoa, I feel like I missed something. Hold on. Front wing adjust the system. Yeah, I found it. Rotate about the primary axis. Then the secondary flap, if fitted, must be a continuous portion and must rotate about the secondary axis. Both the front wing of the primary flap and the secondary flap must include fitted gurneys, and auxiliary components to respective must be attached. Basically, they're telling us, hey, you got to make it. You know your gurney flaps. You got to make sure they still work even with the wing down. Points A and B must lie within the volume of the primary flap and no more than 25 mil from the forwardmost point of the primary flap. Points C and D must lie within the volume of the secondary flap. It's no more than 25 mil from the forwardmost point of the primary flap. This reference points. Make sure you don't go overboard with the wing. Up to 2 pairs of rotation surfaces. Whoa, 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 whoa. Over the intersection with the primary and secondary flaps at the original design position. This is important, chat. No surface of rotation may have a normal which forms an angle greater than 30 degrees to the y-axis. Huh. So just telling you limited. No. How do I say this? That's gotta be something. That's definitely something. Tells you, hey, No going overboard with the rotating surface. That basically tells me don't go overboard on this. Otherwise we have a front air brake. So half of what I suggested for the air brake stuff is invalid. Or at least invalid for the front wing. Okay. Adjustment not controlled by the FIA standard ECU must not result in a decrease in the incidence of tangent lines. Must result in a maximum deviation of for any front wing profiles no greater than 30mm or 60mm. When commanded, this has to be about any adjustment controlled must be about either the primary or the secondary axis. When commanded, switch to one of the two fixed positions, a corner mode and a straight line mode. Not result in a decrease in the incidence of the tangent lines, yeah. Keep things consistent, not asymmetrical. And that remains identical. Magnitude of the decrease must always remain identical. Oh, I know what this is. This just tells us, hey, active suspension, sorry, active aerodynamics, it has to be binary. You can't have any in-betweens. So that's another thing I had in mind, thrown out the door. Have a maximum transition time between the two fixed positions that does not exceed 400 milliseconds. Yeah, pretty instant. Which is a good thing. Means you can still use it as somewhat of an air brake, like a minor air brake. Not as high as I thought, but still a bit of an air brake. Be driven by up to 2 actuators across both sides of the car, which may be electrical or fluidic. Be measured by position sensors, one for each of the actuators defined in P, which are mechanically linked to the front wings. And are connected to the FIA ECU and output analog signals. Be symmetrical. Irrespective of whether the adjustment is controlled by the FIA standard ECU, any fitted front wing and rear wing must, except for front wing fish plates and front wing adjuster fairing, remain in their entirety. Fish plates, is that the mermaid tails that McLaren brought to Canada? Retain the geometric relationship between all elements of the front wing primary flap and the secondary flap. Retain their geometric relationship. Conform to all regulations. Except a couple. So, except for a failure of the front wing adjuster system or during the transition between corner mode and straight line mode, front wing primary flap and... they can only have 2 positions, except for a failure or during transition. Physical stops have to be provided to prevent them from going overboard. The design is such that the failure of the system will result in it returning to its corner mode position. But if the system fails, could you try and control the rate of the rear wing returning to the corner mode? As a failsafe. only be in a state of deployment where the car is stationary or fully inside an activation zone. Article B. Wait a minute, I didn't even read this. Activation zone? Wait, what page were we on? Rear wing. Oh. We were on page 35. We need B7. That's a sporting reg. That's a sporting regulation. Hold on. That's a sporting regulation. I knew it. I knew it. Yeah, I knew it. I knew it. Right. B7. Driver adjustable bodywork and energy deployment limitations. Car and component limitations. Huh. I want to read this section actually. It's a short section, I think. This is pretty new. The permitted driver adjustable bodywork includes the front wing rotation system, defined as before. Driver adjustable bodywork will be considered to be activated when, actually, following command from the driver, both the front wing rotation and it's considered active, yeah. Okay. FI will provide all competitors with relevant information regarding the defined activation zone for a certain... That's bad. I mean, it means you can't use this system anywhere. It's only on straights. Oh, that sucks. That sucks. Man, I thought we were going to see 2011 quali laps again. Oh, that ruins it. That ruins things. The start of an activation zone marked by a solid white line. Yeah, okay. When the safety car is deployed, the system is disabled. It will be enabled when the safety car has crossed the first safety car line on the lap which it returns to the pit lane. Alright, so you can just turn it on in the relevant section. This is just for better racing. This is just for better racing, I think. For reasons of safety, you can disable it. Furthermore, so low grip or poor visibility, you can disable it. And if double yellows or yellow flags are shown in an activation zone, you disable it until it's gone. Okay. Okay. Activation of the driver adjustable bodywork, by which the driver is only permitted when the car is stationary or in any of the activation zones. Wait, when the car is stationary? Can you use this for race starts? That's cool. I think that's the second one we've got. I think that's the second exploit we have. I mean, can you use this potentially for race starts? If your car's stationary on the grid, you can put your flap down. That means you could use it for race starts. It doesn't say, oh, this becomes active after X amount of laps. I don't see that. Driver adjustable bodywork. Only permitted when the car is stationary. I know the activation says yes. Only activate it when they've been notified via the control electronics. That is enabled. LTCS. Listed components. For the driver adjustable during any TCCS, driver adjustable bodywork may not be activated. Cross the line after the safety car. Driver adjustable bodywork will be deactivated by the control electronics the first time the driver uses the brakes. Okay. Failure mode handling's been deleted. I guess because it's happened already this year with Russell in Bahrain. Energy deployment limitations. The absolute limits of the electrical DC power of the ERS kinetic used to propel the car are defined in some articles, along with the limits of allowable energy harvested by the ERS. That's also defined in 5.2.10. The FI will provide all competitors with the following limitations. So each limitation is different, I think. Okay. 5.2.10. What is that? 5.2.10. Oh, unit energy flow. Oh, so this just tells you how it works. 8.5 megajoules. This limit goes down to 8 in places like Monza. It's 5 for sprint quali and quali. Aha, okay. Up to 0.5 megajoules of additional energy may be harvested in each lap. Aha, okay. Cool. This is just, my words. Mine warts. I want to check something actually. For the rear wing. Oh! Oh no! Oh! Alright, chat, pack it up, it's over. My exploit is, banned. My max downforce exploit is banned. Oh no. Back it up, chat. That's one loophole gone. What about materials? Let's just get my material stuff out of the way. Outside the pre-U perimeter. Ah, okay. This is kind of banned. Well, it's somewhat banned, but not entirely. Yeah, this is just no McLaren shenanigans in '98. Honestly, that's all I wanted to know. All I wanted to know. All of my loopholes are practically useless now. It's a shame. I think I've done this at a sort of wrong time. Read this at a wrong time. I mean, I'm not entirely familiar on what you can exploit and not exploit. It's just I need a proper. I need a bit more awareness here and there. And also, look how many pages this is, man. Goodness. Whatever. Alright, I'm gonna leave this for another time in all honesty. Alright, chat. It was nice seeing you.